Hey, okay, I thought I'd try a couple questions from the more practice on trig identities. There's full solutions if you scroll to the bottom, but I thought I would just show you how to do some in video form. Okay, so this is the first question. If you have sine x divided by tan x equals cos x. So this side is your left side. Oh, sorry. And the other side is your right side. So your first step is to pick which side you're going to work with. So I'm going to work with my left side. It's a lot easier to work with the side that looks a little more complicated. So I'm going to write out my left side, sine x over tan x. And then I can see that my right side is equal to cos x. So I'm going to try to get rid of tan x here. So I know using my identities that tan x is equal to sine divided by cos. So I'm going to replace tan with sine x over cos x. So all I did in my first step was I took the tan ratio and I replaced it with sine over cos. Okay, now I've got sine divided by sine over cos. So I know when I'm dividing fractions, I can actually switch it to multiplication and flip the second fraction. So I can do sine over cos, but I'll flip it so it becomes cos x over sine x. And now I can see that I have, if I were to multiply these fractions together, I would end up with sine x cos x over sine x. So I can actually cancel out my sine x's, leaving me with just cos x over 1 or just cos x. And that is what my right side equals. So therefore, sine x over tan x is equal to cos x. Because our left side is equal to our right side. Okay, let's try the next one. So we've got sine x cos x tan x equals 1 minus cos squared x. I think again I'm going to start with my left side. It looks like there's more going on there. So I've got sine x times cos x times tan x. One good strategy is to always get rid of your tan x. So I'm going to actually do the same step as I did last time. Instead of a tan x, I know that tan x is actually equal to sine x divided by cos x. So I'm going to replace tan x with sine x over cos x. And now, same as I did last time, I can see that there's a cos x in the numerator and a cos x in the denominator, so I can actually cancel those out. And all I'm left with is sine x, which is just sine squared x. And I know from my trig ratios, I'm just going to scroll over to them. I know my Pythagorean identity, sine squared x plus cos squared x equals 1. I'm just going to write that over here. Sine squared x plus cos squared x equals 1. That's my Pythagorean identity. So I also know that sine squared x is equal to, if I move the cos squared to the other side, 1 minus cos squared x. So I can replace sine squared x with 1 minus cos squared x, which is what my right side is. So therefore, sine x cos x tan x is equal to 1 minus cos squared x, because I just showed my left side is equal to my right side. Okay, next question. 1 minus cos squared x over sine x is equal to sine x. So I'm going to pick the left side again. So on my left side, I have 1 minus cos squared x over sine x. I'm going to do the same move I just made. I'm going to replace this with sine squared x. Remember we just showed that sine squared x, sorry, thought I had a highlighter. Sine squared x is actually equal to 1 minus cos squared x. So instead of 1 minus cos squared x, I'm going to replace that with sine squared x over sine x. Now I have 2 sine x's on top and 1 on the bottom. So what I can do is cancel one of those out. So that just leaves me with a single sine x, which is what was on the right side. So therefore, 1 minus cos squared x over sine x is equal to sine x. And that's it. Let me try one more. Let me try the fourth one. Sine squared x plus sine x cos x over tan x. Sine squared x plus, I already forget. Feel free to stop if you had enough. Sine x cos x over tan x. Sine x cos x over tan x equals 1. Okay, so clearly my left side looks way trickier. So let's start with my left side. So I've got sine squared x plus sine x cos x over tan x. And I have to make that equal to 1 somehow. So let's, you know what? Like we just did in a bunch of other questions, a good strategy is to get rid of the tan, make everything in terms of sine and cos. So I'm going to do that first. So instead of a tan, remember tan x is equal to sine x over cos x. So all I did in my first step was replace tan x with this fraction. And now I'm going to do like I did before, a fraction and a fraction, like that's tricky to work with. So I'm going to write it as sine x cos x times cos x over sine x. So I'm just going to highlight this because that's what happened to my denominator. I flipped it and I changed this division to a multiplication. And now I can see that I have a sine x in my numerator and a sine x in my denominator, so I can cancel those out. So all I'm left with is sine squared x plus, I have cos x times cos x, and cos x times cos x is actually just equal to cos squared x. And we know sine squared x plus cos squared x is our Pythagorean identity, which is just equal to 1. So there you go. My left side equals my right side. And they just get trickier and trickier as you go. But I thought I'd show you a few easy ones where it's just like replacing stuff. Just a couple tips. Again, feel free to stop watching if you feel good about this. Replacing tan with sine over cos is always a good strategy. Whoops. Because lots of times it's easier to write it in terms of sine and cosine. Common denominators is a good strategy. So if you had something like 1 over cos x plus sine x or something, a good strategy here would be if you tried to make a common denominator, so I'd have to multiply this top and bottom by cos x, and now I'd have a common denominator. So common denominators are a good strategy. Sometimes factoring is a good strategy, and the factoring that often comes up is something like a difference of squares, where it's like x minus 3, x plus 3. So recognizing a difference of squares means this term and this term are they're both like perfect squares. You can square root both of them. So how that would look with trigonometry would be if you had something like sine squared x minus 1, I can take the square roots of both of those. So the square root of sine squared x is just sine x, and the square root of 1 is just 1. So it would be like sine x minus 1, sine x plus 1. And it totally works, right? Because if you were to FOIL it out, like expand it, you get sine squared x plus sine x minus sine x minus 1. So difference of squares is a good strategy. Sometimes there might even be like, remember trinomials? So let's say you had x squared plus 2x plus 1. You know how you're looking for things that multiply to 1 and add to 2? So in this case, it would just be x plus 1 times x plus 1, because 1 times 1 is 1, and 1 plus 1 is 2. So how that might look in trigonometry is sine squared x plus 2 sine x plus 1. And the numbers you're working with are always small, so they should be pretty easy to factor. So if we're trying to find something that multiplies to 1 and adds to 2 sine x, or adds to 2, I mean, that could be sine x plus 1 times sine x plus 1. Right? Because like this 1 times 1 would equal 1. And then 1 plus 1 would be our 2 here. So if we were to expand it, we get sine squared x plus sine x plus sine x, which is where we would get the 2 sine x. And then 1 times 1 would give us that. Not that we want to expand it, but I'm just trying to show you that that's how factoring works. So yes, it looks complicated because there's a whole bunch of sine and cos and tans in there, but really it's the same as just regular factoring. Okay, so that's what usually comes up. Difference of squares, if you see something that looks like that, or simple trinomials. Those I think would be the main two.